Hello, and welcome to this keynote session, forming part of the 11th Annual Analysys Mason Telecoms Summit. My name is David McElroy, and I work as part of Analysys Mason's online events team. Now, you may have already watched some other sessions leading up to this one. However, I just wanted to run through a couple of points to make sure that you get the most out of this and all of our other summit presentations. Firstly, please remember that all sessions are available to you on demand, meaning that you can watch them in an order and at a time and at a date that suits you. You're, of course, welcome to rewatch the sessions as well. As well as this keynote session, we have a selection of other keynote sessions, breakout sessions, and a 5G panel session from you to choose from. You can access all sessions via the event homepage. Now, once you have entered your chosen presentation, you have the ability to connect with our presenters on social media. You'll be able to access a number of useful resources, and you'll be able to submit questions. Please use the console widget marked Q&A to submit your questions to the speakers. Now, as these sessions are on demand, please bear in mind that our presenters will pick up your questions and respond to you via email in the coming days. Once the session has ended, you'll be able to go back to the event homepage where you can simply return and choose another presentation to enjoy. Now, I have the pleasure of introducing partner Tom Rebeck and principal analyst Michelle McKenzie. So I think Tom is going to kick off this session. So Tom, I'll pass over to you whenever you're ready.
Great, thank you, David. So in the session today, we're going to be talking about private networks and edge computing. We're going to cover three things. Firstly, we'll talk about why we think these two technologies are a good fit. Second, we'll speak about why we're seeing relatively little activity so far. And then third, we will talk about what operators can do to benefit from the future growth in the market for combined private networks and edge, and maybe more generally just about how operators should think about this opportunity. But before we go into that, we're going to first explain what we mean by private networks and edge.
So what is a private network? Well, a private network is a cellular network that is self-contained. It's built specifically for an individual enterprise. And these networks are most commonly deployed in a building such as a factory or across an industrial site, so connecting several buildings. And typically a private network is understood today as a fully dedicated on-premises solution where the enterprise has a radio and core network for their sole use. But new private network models are emerging based on public network assets, such as a slice of the public 5G network.
Now let's talk about edge computing, and each organization involved in edge seems to have a slightly different view of the term. We're not going to provide the definitive answer to a definition for edge, but would you give a sort of general idea, general principles? So over the past decade or more, the trend has been away from local store and compute. More and more is being done centrally, and this is shown in the chart by the grey box on the right-hand side. Now edge runs counter to this trend, and more of the compute and storage is being done closer to the edge. So at the extreme, this is on the device itself. So that's what we have on the far left of the slide. Alternatively, the edge can be within the user premises, within the enterprise premises, but not on the device. So that's shown in the second box on the right-hand side of the chart. That could be an edge server in a factory managing some robots, for example. We've grouped the next three positions as network edge, as all of these can be located in the telecoms network somewhere. It could be at the cell site, it could be in a central office, or deeper into the network, for example, in a metro data center. And for the foreseeable future, that's where we're most likely to see deployments in the metro data center, more likely to see deployments there than, say, in cell sites or in central offices. Now, the view here is very much for a telecoms operator, but a third party could replicate some or all of these investments. So it would be relatively easy for companies other than telecoms operators to invest or build out edge nodes in metro data centers, say. Now, a confusing thing is that any of these locations in blue is being called edge computing. So edge really isn't a location. It's more easily defined by what it isn't. It isn't the central data center or public cloud location. It's where the compute is happening closer to the device or even on the device. The second part of the definition is the relationship between the edge node and the cloud. So services are always edge to cloud. The edge node is always working in conjunction with the central system on the cloud. Before we move on, I also want to make note of the names of these locations. As you can see from the slide, some of the locations have multiple names. So what we're calling here the customer edge or private edge is also sometimes referred to as on-premises edge or enterprise edge. The same with network edge, sometimes that's also called public edge. As a final point, as we move through this presentation, we're mostly going to be talking about edge nodes in the enterprise premises or in the metro data centers, as this is where we see most of the investment today. Now, let's talk about why these two elements, private networks and edge computing, are complementary.
So private networks and edge computing are complementary goods, and complementary goods are products that are bought and used together. So a common example of this would be milk and breakfast cereal, for example. So while both can be consumed without the other, they work better together. Private networks and edge compute are complementary goods as each one adds value to the other, and especially with respect to the following enterprise requirements that we're showing on this slide. So let's take support for low latency. Enterprises want to process their operational data on or close to their premises because the applications they are running have low latency requirements. Private networks combined with edge compute can support low latency. Edge computing locations enabled by a private network are typically 10 milliseconds or less away from the data source, compared with public cloud data centers, which can be more than 100 milliseconds away. And on the second point, reducing traffic costs, well, this is enterprises wish to avoid the cost of transporting very large data sets over long distance networks to be processed in central clouds. We could take the example of computer vision. Connecting 50, 100 cameras would create lots of data, but they might not need to transport all of that data to a central cloud. Then there's the point around user control. Enterprises want to retain control of the network and their data, and a combined private network and edge compute solution allows them to do that. Privacy, of course, is an important issue. Security concerns are top of the mind, and customer edge is associated with a highly secure and private solution. If we think of the example of checkout-free supermarkets, and Tom's going to talk about this more a bit later, where computer vision is used, customers may not want their image uploaded to the cloud over the internet. So again, a combination of a private network and edge can address some of those concerns. Then finally, enterprises often need to comply with local regulatory requirements. So data may need to remain within national boundaries. And this will be especially important for certain regulated industries, such as utilities or oil and gas. Private networks and customer edge can satisfy enterprise needs to comply with such regulation. I think a final point to make is that not all private networks will need edge, and definitely not all instances of edge will need a private network. On balance, private networks probably need edge more than vice versa.
So we've heard from Michelle about the theory of why private networks and edge should make a good combination. Now, let's look at how that could work in practice with the example of checkout-free stores. Amazon's pioneered this technology. It has 11 of these stores in the US, and it has 6 in the UK, 6 in London. Now, you probably know how these work already, but if you don't, I'll just give you a quick summary. First of all, you generate a QR code on the Amazon app in your phone. As you enter the store, you then swipe that code into a reader. You then walk around the store as usual, picking up whatever you want. You put it directly into your bag, and then you leave without having to check out. While you're going around the store, a series of cameras and sensors is tracking what you've taken, and then it will charge your Amazon account later on. Now, it isn't clear to me if the Amazon stores right now are using edge nodes or private networks in these pilots. I suspect the cameras are still hardwired, and it may be using cloud rather than edge computing. But as the technology rolls out and the stores become more popular, it seems very likely that both these technologies will be employed. Firstly, because hardwired cameras make the store layout very difficult to change. Private 5G would be more flexible. And in these stores, these Amazon stores, they're using probably hundreds of cameras. The whole ceiling is covered in cameras. Edge computing would also reduce the amount of latency that travels back, the amount of data that travels back to the cloud, and also increase reliability. There's also a privacy element to this, and Michelle touched on this a second ago. The only information that Amazon really needs in the cloud is what you've bought. It really doesn't need to store images of you walking around the store, and you probably don't want those going up to the cloud either. It's interesting to see that obviously it's Amazon that's pioneered this technology, but it's not just Amazon using it. So Tesco, the UK supermarket, has announced that it's going to be opening its first store using similar technology at some point this year. And Aldi, another supermarket, a German discount supermarket, has also announced that it's going to launch a checkout-free shop in the UK. So technologies that just a few years ago were seen as leading edge are now becoming mainstream. The checkout-free store is just one example of private networks working together. And it's one that we know that operators are working on. So SK Telecom has talked about this use case. And earlier in October, Verizon announced that it was working with Deloitte to combine 5G and edge for the retail sector. Other examples of sectors combining edge and private network include ports, factories, and in distribution centers. Okay, so we've talked about how and why edge computing and private networks are a good match. We've seen some examples of how it could work, but if we actually look at the data, there still isn't very much happening. So we've got detailed information on over 200 private networks involving over 40 telecoms operators. So there's a lot of activity going on in private networks. In edge computing, it's probably a little bit less activity, but we're still seeing an increasing amount of activity. So at least 50 operators have said that they're doing something in edge computing, and more than 30 of those have either pilots or even commercial customers for their edge solution. But as you can see from the chart, there's very little crossover between the two. So we've looked at the various releases and public statements about private networks, and of the 217 private networks where we have full information, so that's information on who the customer is, who the vendors are, and so on. So of those 217 private networks, only 24 involve edge computing, and of the 24, telecoms operators are the prime contractor in just 9. So we have examples of operators using private networks without edge. We have the opposite of operators deploying edge nodes separate from private networks, but we're seeing very little crossover between the two. Now, Michelle and I were a bit surprised when we saw this. So over the past few weeks, we've been talking to operators involved in private networks to see if this is an accurate reflection of what's actually going on, and it seems like it is. So as one example, we talked to a company involved in private networks. It has a test bed with a number of customers exploring how they can use private 5G networks, and none of their customers so far is using it alongside edge computing. So despite the theoretical benefits of the combination, it's still early days, still not much happening yet. Now, if we don't see much overlap between private networks and edge today, we do expect this to change. And it's an open question as to how much overlap there's going to be, so how big that green area will be between private networks and edge. But we do expect certainly a much greater overlap than we're seeing today. And if we're looking at this in 5 years' time, then we expect probably the majority of private networks to be deploying at least some aspects of edge, and maybe that number will be as high as 75%. So edge computing needs to be a major part of any private network strategy.
So in this chart, we're showing the outlook for private network and edge compute spend until 2025. Network spend, and that includes the spend on the radio and the core network, network design and implementation of the network, will grow to around $5 billion US. And edge compute spend will reach $34 billion by 2025. But I should add that that's not just the customer edge part of edge compute spend. So this is just the outlook for the next few years, but the market will be worth much more. Private networks and edge compute are really 10, 15-year opportunities, as was cloud. Suppliers that are building a proposition now will see much more revenue in 2030 because this is a long-term opportunity, similar to the IoT market where operators that started out over a decade ago are only now beginning to see some significant revenue. An enterprise spend on private networks and edge will grow slowly because there are fairly important challenges that they have to address. First of all, the market is highly bespoke and custom requirements create barriers to scale. Sector requirements are very diverse. What the manufacturing sector needs can be different from the transport sector. And of course, many industrial environments are brownfield sites. They already have many networking solutions in place. So the average lifetime of some sites, if we take a factory, for example, is around 20 years. So it's going to take time to displace the existing technologies. But the point here is that private networks and edge compute are potentially very big markets, but it's going to take time to build.
So from what we've just seen, both the private networks market and the edge market will be worth billions of dollars. Now, this is small relative to the telecoms market overall, but it's still significant incremental revenue, and it's a revenue stream that's growing very quickly. So the question is raised, why are we seeing so little movement so far? Now, from the conversations that we've had, there are, I think, a variety of explanations, some of which will hold in the long term, but many of which won't. So let's go through the possible explanations. So firstly, many of the private network projects right now are being deployed simply to replace one access technology for another. We're still at a very early stage. So for example, we've heard of private 5G being used in a factory so that the existing cabling could be removed. In other cases, we've heard of private 5G being used as a replacement for Wi-Fi. So in these examples, the customer's not making any changes to the back-end system. The private 5G network is simply connecting to whatever was there before. I expect this is pretty common for quite a lot of customers. The move to private 5G is a first step, that it has its own drivers. The move to edge computing will be a subsequent step, but one that has a different dynamic and different drivers. And we probably shouldn't expect them to happen in lockstep. Even the shift to private 5G, it's quite a big disruptive change. But I think the shift to edge will happen for many of these organizations, driven more by the development in cloud strategies than the change in the access technology. Secondly, edge is a relatively new technology. So AWS only launched its Outpost product in 2019. Microsoft released Azure Edge Zones in 2020. So it's going to take years for expertise and understandings of these technologies to grow, just as it did with products like AWS S3 and EC2, the core cloud products. We also don't have standards for edge computing. Again, this is something that's being worked on. So we are seeing the market rapidly developing, but it all takes time. Thirdly, there are many solutions that simply don't need edge computing. So even in an advanced application like smart glasses may just need a good connection to a remote expert. We also see many private networks being installed simply to provide good coverage for basic services where there's no public network connectivity. For example, we know of opencast mines that come into this category, the private networks installed to provide basic connectivity to smartphones and tablets rather than to do anything more sophisticated. Again, some of this will change in time. Sites that have a highly capable private 5G network in place may be tempted to explore how they can take full advantage of those capabilities. But equally, there will be some sites that use private 5G with no edge resource required. And then finally, there are probably some services that run today, that are running applications today that we don't think of as edge computing, but arguably could be classed as edge computing. So an example of this could be private networks running a push-to-talk application, running on the same server as being used to run the core network. It's not really thought of as an edge application, but arguably it's an application running at the edge, so maybe it should be classed as such. In summary then, the key point here is probably that we shouldn't expect too much too early. The upgrade to a private 5G network is not moving at the same rhythm as the move to cloud and edge computing. But over the next 5 years, we do expect these technologies to increasingly work together. And this creates an opportunity for telecoms operators, but again, it's going to take time to emerge.
So initial deployments of private 5G, private LTE, and customer edge will be on-premise, on the customer premise. As I mentioned earlier, the majority are on-premise today and consist of fully dedicated radio and core networks that are installed on site. We expect that when edge compute solutions are deployed more widely, they will tend to be on site as well. So let's first consider some of the benefits of this model for the enterprise. So these are highly customized networks tailored to a specific enterprise requirement. Cellular networks provide a robust overlay solution for supporting new applications rather than extending fixed cabling, for example. And the private network and the customer edge satisfy requirements for data privacy and security, as we mentioned earlier. But there are also challenges that the enterprise needs to consider with this model. The networks are relatively high cost compared to Wi-Fi, for example, and they don't scale easily. They're fairly complex to deploy and manage, and even a pilot will involve significant upheaval and overhaul of business models. But from a supply side perspective, for operators, they can participate in this new market because they have the skills to design and implement the network. They have partnerships with network equipment providers to source the radio and core network components, and they have partnerships with public cloud providers to deliver the edge compute solutions. But of course, there are also disadvantages for operators with this model. The operator has to assume the role of a reseller of network infrastructure, so they're going to have less control over pricing and less scope to differentiate their offer. And they'll also be competing with a large number of other players, including their network equipment partners, systems integrators, and other specialists. But in the future, more of the solution can be located off the customer premise. So at the other extreme, enterprises could source a network solution from an operator that uses the public mobile network. Now, this is an emerging solution, and it will become more relevant as operators roll out their 5G networks. In this scenario, the enterprise would use a private slice of the public mobile network with SLAs to allocate network resources to meet the enterprise needs. The enterprise could deploy a network edge solution as well, provided by the operator. So in this case, the hardware for network edge is installed on the telecoms operator's network and managed by the operator, but it offers similar attributes to a customer edge solution. Now, network models that use the public network assets have some clear advantages for enterprises. That they should, in theory, provide a cheaper solution. They lower the capex. They're based on a multi-tenant approach. And indeed, the business model could evolve to a pure OpEx model over time. And the network and edge solution should be easier to scale because they're based on standardized network assets that are available globally. And they'll appeal to enterprises that do not have the IT resource to maintain and operate a network internally. However, there could also be more challenges. Enterprises will have less control over the network and the edge solution, and they may have concerns about SLAs and the level of support that an operator can provide. If we think about the operators, well, the advantages are clear with this model. They'll be able to monetize the private network and edge opportunity based on their own network assets. They'll have more scope to differentiate their offer from other competitors. And they should also be able to reach new segments, new customer segments with this model, such as the SME segment. Interestingly, a survey that we conducted earlier this year on enterprise adoption of private 5G and enterprise intention for private 5G showed that most enterprises associate the private 5G offer with the mobile network operators and see them as a major potential supplier of these networks. So operators definitely have an opportunity to build on this association. But long term, both models will sit alongside each other. The main takeaway here is that the on-premise versions of private networks and customer edge are the first step to longer-term multi-tenant public network models.
So let's turn to what the operators are actually doing. And I said before that there isn't a huge amount of activity, but there are some announcements in the public domain. So each of the 9 operators that you can see here at least have some commercial customers or pilots that are using the combination of private networks alongside edge computing. I'll pull out a couple of examples. So firstly, SK Telecom in January this year, so January 2021, it announced that it was working with VMware and Dell to create an edge and private 5G solution. It's not talked too much about where they are with this technology, but interestingly, it is looking to create a single box solution. So both the private network and the edge computing could be run from the same server. Now, obviously, that will involve less integration costs. It'll be simpler, a simpler setup. So that should appeal to smaller enterprises. It also, I think, raises the prospect of customers buying one of the capabilities first and then adding the other later. So the customer could buy the solution to support a private 5G network and then add edge applications later on. And as we said before, there's a different dynamic between edges and between private networks, so that may work. They may be working on a different time scale. Another interesting example is Verizon. So it won a private 5G contract in the UK with the Port of Southampton that it's delivering with Nokia. It's also involving edge compute. Now, in the release, when it was talking about that deal, it said Verizon's private 5G is the foundation for a completely dedicated edge compute infrastructure. And perhaps more than any other operator, Verizon's been pushing this combination of edge and private networks. At its Capital Markets Day earlier this year, it mentioned edge more than 50 times. So it was basically once every 2 minutes it was mentioning edge. And the other operators you can see here, Orange, Telefonica and Vodafone and so on, they've at least mentioned the combination of edge and private networks in their public statements. So we do have some activity from operators. It's all a bit muted still, but I would expect to see more in the next year, 18 months. So let's look at some of the weaknesses for operators as they look at this new market. Michelle's already mentioned the reliance on third parties for the technologies as a potential weakness, both for private networks and for edge computing. Telecoms operators are going to be relying on vendors who are selling the same products through other channels and in some cases also selling this direct. Operators need to consider about how strategies for mitigating this weakness, and I'll talk more about that in a minute on the next slide. But it is worth keeping in mind that in most cases, the technology vendors aren't interested in selling direct to enterprises. They need channel partners, and operators are well placed to serve that need. Some of the other weaknesses, though, I think require more thought and possibly more change from the operator. So the second point, as we know, there are going to be some competitors who are more agile and more aggressive than operators. So operators need to think about how they can best be structured to go after this opportunity, especially as it cuts across many of the other capabilities and strengths that they have in connectivity and cloud and security and in other areas. And operators may need to make organizational changes to pursue this opportunity. The final point is perhaps more important, similar, but I think probably more important. So operators, like any other business, they're more likely to act if they feel threatened. If private networks or edge represented some sort of threat to the core revenue, then they'd be very likely to act and act quickly, act aggressively. But there's no real obvious threat to the existing business from either private networks or from edge. They both represent an opportunity, but operators obviously have plenty of areas, potential areas for investment. So representing an opportunity doesn't make them unique. That said, there are perhaps two ways in which private networks and edge are slightly different from the other opportunities. First, there's this link between private 5G and future versions of the public 5G network. That creates an obvious relation to the core business. Private networks and edge shouldn't really be thought of as a different growth area, but they're tied to the existing business. Second, there's the option value that an investment in private 5G and edge can create. The short-term revenue might be fairly limited, but it'll grow and it'll open up new areas of opportunity. And I think private networks themselves are an example of how investments can create opportunities in the long term. So the operators that invested early in IoT are now the ones that are best positioned in private networks today. As an example of that, you can see the work that Vodafone's doing with Porsche. So Vodafone's building a private network for Porsche that it's using both in its factories and in its testing ground. Now, I suspect Vodafone wouldn't have won that contract if it hadn't built up its relationship with Porsche over the past decade. So it's reaping the rewards of a long-term approach. And operators need to do something similar in private networks and edge if they are to create this option value in the longer term. Let's look then to operator strengths and what they can do to differentiate their offers. And I think they do have assets to gain a strong position in the market. So firstly, the first point on customer base. So obviously, operators, particularly enterprise operators, have a large base of customers. Secondly, on the enterprise willingness to deal with operators, we know from our research with enterprises, they're often willing to buy services other than connectivity from telecoms operators. And they're often, I think, more willing to buy these other services, than telecoms operators actually realize. On the third point, and this is kind of related to the previous one, enterprises are keen to reduce the number of technology suppliers they work with, and this comes through very clearly in some of the surveys that we've done. So the prospect of adding a private network provider, adding a separate edge supplier, and then adding other service providers on top of that is not a particularly enticing one for enterprises. So the sort of solution that SK Telecom is developing with a single box is one that I suspect many enterprises will appreciate, particularly when we're talking about mid-size and smaller firms. The next point is around operator skills, and particularly the larger enterprise-focused operators have the capabilities in areas that are complementary to edge computing. So Orange has something like more than 2,000 cloud specialists. BT has a similar number in its security team. So these operators, I think, are well placed to put together something that doesn't just involve private networks and edge, but also other forms of connectivity, along with security, cloud computing, systems integration, and other services. And in each country where these operators are present, there are very few organizations that have a similar range of capabilities. It's relatively rare and a fairly unique strength, I think. Now, obviously, the bundle of different services isn't something that's available to all operators. It's only the larger operators, such as the ex-incumbents, that have those sort of skills. Smaller operators are going to need to partner if they're to offer the same sort of bundles. On to the next point about multi-vendors, and this is really related to the previous point. So operators are often partnering with AWS, with Azure, with Microsoft, with Google, and sometimes with others. So this matters, as I think most enterprises are looking to use a mix of different cloud solutions, and they want service providers who can support that. The penultimate point is about the combination of customer and network edge. So most of the activity that we've been talking about today is around the customer edge, but as Michelle was saying earlier, that's changing. And some customers will want solutions that combine both customer and network edge and maybe different flavors of the private network. Operators should be well placed to offer those combinations. Some operators like Verizon, like SK Telecom, are already working on solutions to do just this. Finally, in some countries, operators do have some degree of control over spectrum used in private networks that they can leverage. This may not be a sustainable differentiator, but it's certainly there in place in some countries today. So the key point that I'm trying to make on this slide is that operators have a lot of capabilities. They've got a lot of assets on which they can build a differentiated offer, even if the underlying technology is relying on essentially commodity components of private networks and edge computing that they're taking from third-party vendors. So just to wrap up, I'll summarize some of the main points and provide some recommendations to operators. So firstly, while there's not a huge amount of activity yet, we do expect many more private networks to include edge computing in future. Operators could take a leading role in this, but they do need to be more proactive in combining the two technologies. They've not done enough to talk about how these solutions work together or to promote why they should be the supplier of those combined solutions. The second, operators have many ways of differentiating what they're offering and building a strong position in the market, again, even if the components they're using are the same as their competitors. Operators do need a stronger story, though. Finally, operators need to take a long-term view on this opportunity. It's unlikely to generate significant revenue in the next year or two, but nevertheless, operators do need to take steps now to benefit from the growth in the market in the longer term. And with that, I will close the presentation and hand back to David.
Thank you very much, Tom. And thank you very much, Michelle, for that informative presentation. And thank you to everyone who has chosen to attend the session. Just before you go, I'll just remind you of a couple of points. You can access the useful resources. You're still able to submit a question to our presenters, who will get back to you via email in the coming days. And please don't forget to connect with our presenters on social media, particularly LinkedIn. And you can also follow Tom on Twitter as well. And just very lastly, please allow me to thank you once again for attending. You're welcome to make your way back to the event homepage, where you can choose to enjoy another one of our summit presentations. So we hope you enjoyed this session, and we look forward to welcoming you to another. Thanks again. Take care.